Let's solve Unit 1 Discrete Structures and Optimization questions. The Boolean expression for the following would be, they have given a function f of a, b, c. It means there are three variables here. What is this d of a, b, c? This denotes the don't care condition. So far we have solved nearly 9 previous year question papers, but this is the first time I am seeing don't care condition. What is actually the don't care condition? Usually when they give f, we have to place 1 in the respective position. When they have mentioned certain positions for don't care, just mark x or some other notation. This don't care condition will be considered for grouping purpose. We will see how to do that in the problem now. Let's take 3 variable K-map now. So this is for A and this is for BC. We have 0 and 1, which is A dash and A. Then here it's a 2 variable part. So we have 0, 0, 0, 1, 1, 1 and 1, 0. Why have we kept 1, 1 first? Because we have to change only one bit at a time. That's why 1, 1 comes first and 1, 0 comes next. Wherever you have 0, just place the complement part. So 0, 0 becomes B dash C dash, 0, 1 becomes B dash C. 1, 1 becomes BC, 1, 0 becomes BC dash. What is 0, 0? It is 0. 0, 0, 1 is 1. Just get the 8421 numbering. You can find the numbers correctly. 0, 1, 1 is 3. 0, 1, 0 is 2. 1, 0, 0 is 4. 1, 0, 1 is 5. 111 is 7. 1, 1, 0 is 6. What are the positions that have been given in the question? 0, 2 and 6. This is 0, this is 2 and 6. Since the don't cares are also given, we have to mark them also. We will use the notation X for this problem as I said earlier. First position, third position and fifth position. While grouping, what are the possibilities for ones here? We can group this part. So this is BC dash, irrespective of the value of A, BC dash is 1 in these two places. Since don't care is present here, we can treat this as alternative of 1. If we do so, then we can mark the complete row as a grouping part. Now what will be the variable that has come for this top row grouping? It will be A dash. Irrespective of any value of B and C, whether it can be B or B dash, C or C dash, what is constant here? A dash is constant. So we will mark A dash here. You can find A dash plus BC dash in option number 4. Option number 4 will be the right answer. Now you could have understood what is the use of don't care conditions. When don't care positions are given, you can use them for grouping along with the ones. The next doubt that you can get is, can I group only these two? It is not possible. The grouping has to be done along with the ones. In case you have a 1 here and you have 2x here along with another 1 here, I can group this together. This is a possibility. You cannot do this grouping here. The don't care position should accompany with 1. Only then you can consider them for grouping. If you practice 1 or 2 problems with don't care conditions in 3 map variable and 4 map variable, you will definitely understand this concept. Next question, which of the followings are tautology? I have given the result of 3 basic operations, or, and, implies. We have to find whether all these expressions are having 1 in the last column. Tautology is true for every value. First we will start with A expression. So what is P or R? Except for 0, 0, all other places will have 1. This is 0 and this will be 1. Now we will place the result here. The next variable that we have to consider is P. So let's take the value 0, 0, 1, 1. Now we have to apply the implies operator between this part and this part. So what does the implies operator say? It says when the first proposition is 1 and the second proposition is 0, you will have a value 0. Rest of the cases it is 1. Check whether you have 1, 0 anywhere. Yes, you have 1, 0 here. So this is marked as 0. The rest of the places will stay as 1. Do you get all ones here? No. So this is not a tautology. Any option that involves A can be removed. Next we will go for expression B. P and R will have 1 only for 1 and 1 combination. The rest of the places will have zeros. Now we have to find P implies P and R. So let's take P's value here. In order to not confuse you, I am rewriting the values of P column and P and R column and then computing the results. So P and R will have 0, 0, 0, 1. Check for this condition once again. We have 1, 0 combination here. So place a 0 here and the rest of the places will have 1. Do you have ones in the final column? No. So this is also not a tautology. When you remove third option because it has B, we know the answer is C, D and E. Last time I could not solve all the expressions because it had 3 variables. This time since every expression is having only 2 variables, I would like to solve C, D and E also. For examination point of view, once you decide it is not option 1, 2 and 3, you need not check C, D and E. You can clearly mark option 4 as the right answer. This is just to tell you how to do truth tables with different operators. Make sure you solve minimum number of expressions in the exam so that you can save some time. We will start with the C expression. We have not P first. We have to just reverse zeros and ones here. What is P implies R? When you have 1 and 0, that place will be 0. The rest of the places you will have 1. This will be not P implies R. So it is in order. We can compute this way itself. 1 and 1 will give 1. 1 and 1 will give 1. 0 and 0 will give 1. 0, 1 will give 1. You don't have this particular set in this expression. So all the values are 1 in the last column. It means C is definitely a tautology. Next we will check for D. We have to compute P and R. So we will write the values of P and R here. We have to write for implies operator. This will be 1, 1, 0, 1. Now we have to directly apply the implies operator between these two expressions. Do you have the combination of 1, 0 here? You don't have anywhere. So all the values in the final column will be 1. D is also a tautology. Let's check the final expression E. We have to find negation of implies operator. Let's first write the value of implies operator. 1, 1, 0, 1. The negation of the implies operator will be 0, 0, 1, 0. So let's write 0, 0, 1, 0 here. Then write the P column completely. 0, 0, 1, 1. Now find the implies operation. 0, 0 will give 1. 0, 0 will give 1. 1 and 1 will give 1. 0 and 1 will give 1. You don't have this 1 and 0 combination. All the values in the final column are 1. E is also a tautology. We have solved it using the truth table. In case if you are not comfortable with this truth table format, what you can do is you can go for an alternative strategy of reducing these expressions. If we have to reduce these expressions, then we have to know this particular rule. P implies Q is equal to not P or Q. Using this only we are going to solve all these expressions. Let's take the A expression. P or R implies P. Now we have to consider this expression to be P and this one to be Q. Not P or R or P. This is equal to, we have to apply the negation inside. Negation of P, negation of R will become and, then it is negation of R or P. Now when you group them, this will be not P or P and negation of R. This will be equal to 1. This can be taken as, if P is 0 and 1, negation of P is 1 and 0. 1 plus 0 or 0 plus 1. Both are going to give you only 1 here. So not P or P will always be 1. This AND will be retained and negation of R is taken. Now let's take R is equal to 0 and 1. Negation of R will be 1 and 0. When you perform AND operation with 1, it is 1. But when you perform AND operation with 0, it becomes a 0. So this is not a tautology. Tautology should give 1 in all the cases, not only for specific case. Since there is a possibility to get 0, A is not a tautology. Let's get into the B expression. P implies P and R. Now let's consider this to be P and this to be Q. This will be negation of P, or the complete expression of Q is written here. Negation of P or P, and this will be negation of P or R. This is equal to 1 and some kind of expression again. So whenever this expression is going to be 0, this whole expression will turn to 0. So this is negation of P and this is R. When you do OR operation here, it is 1, 1, 0 and 1. So at least for one case you have 0 in negation of P or R. This case will bring a value of 0 when you perform AND operation. Since one case is giving 0, we cannot consider this to be a tautology. All the cases should give you 1. So this way we can say that A and B are not tautology. From these two evaluations also, you can conclude option number 4, C, D, E as the answer. Now let me tell you how to solve C, D and E. This is for your learning purpose. Negation of P implies R. Let's first solve P implies R. Negation of P implies not P or R. Now this should be taken as P and this should be taken as Q. This will be negation of P, or this complete term has to be taken as it is. Negation of negation P will be P, or negation of P or R. This term will be reduced to 1 or R. Now let's take R is equal to 0 and 1, and then you have to do OR operation with this one. For any case of R, you will get only 1. Since it is always 1, we are telling C is a tautology. Let's get into the D expression. P and R implies R. Let's evaluate this first. P and R implies, we'll go with negation of P or R. Now let's consider this to be P and this to be Q, which is equal to negation of P and R, or this complete Q term will be placed here. You have to apply the negation inside. So this is negation of P, negation of AND will become OR, and negation of R will become negation of R. This is negative R, or the term will be placed like this. So everything is OR operation here. Not P, together will give not P again. Not R will give 1. When one is going to have OR operation with any value, it will always result in 1 only. So this way we can say D is also a tautology. Let's get into the E expression. Negation of P implies R implies P. Let's take it overall first. This is negation of P implies R. We have to apply negation to the whole part, or P. So this is completely P and this is completely Q. From this we can say negation of negation becomes again P implies R or P. This will be negation of P or R or P. We can rearrange this as negation of P or P or R, which is equal to 1 or R. Again we are ending with the same kind of expression. So this is always 1 irrespective of the value of R. So E is also a tautology. You can also solve this problem in this way, unless and until you have good practice in these evaluation kind of questions. I will personally suggest you not to go for this. When there are only 2 variables, you can go for truth table model. If you are completely not comfortable with truth table model, you can take this way. Next question. Which of the following have truth values if universe of discourse consists of all integers? If you have worked with December 2023 question paper, you would have got the same question. Out of the 4 expressions were given in December 2023. We have a different C expression this time. Let's start with A. For all symbol is actually missing. It is missing here as well as it is missing here. So we can take it as for every number. And this symbol is there exist or for some value, or you can take there is some value. What does A statement say? There is an integer m that is bigger than n square. When we say m is bigger than n square, it should be big by at least 1 because they are given here as integers. This is true when we take m is equal to n square plus 1. When the official answer marked this last time as false, I told the concerned book's solution is telling that it is true. So this is true. Let's go for B. There is a n for every value of m that is less than m square. N is smaller than square of every integer is the exact statement of the expression. This statement is true since squares are always greater than or equal to 0. If it is 1 square, it is 1. If it is 2 square, it is 4. Even if you take minus 1 the whole square, this is going to be 1. Even if you take minus 10 the whole square, it is going to be 100. All the squares will be greater than 0. In that case, we can say any number can be less than the square of every other number. B is also true. Next, we will go for C. There is a n value and there is a m value. And when we compute the sum of their squares, we get a value 5. Is there any possibility to do that? Yes, there is a possibility. Take n is equal to 1 and m is equal to 2. 1 square is 1. This is n square. 2 square is 4. This is m square. Add them together, you will get a value of 5. N square plus m square will be equal to 5 for some value of n and m. They have given there exists a value. Even if one value is there, this expression is true. This is what is given in the statement. So this statement is absolutely true. So far A, B and C are true. We know C is true. This fourth option did not include C. So we can rule this out. Even if you have a doubt whether A is there or not, we know B is true. Since B is not included, we can rule out. Now we know B and C are true. Just check D and E. You will automatically know what is the answer. For D expression, there is a n value and there is a m value. N square plus m square is equal to 6. Just now we found n square plus m square can have 5. What is the other possibility to do this? We can have n is equal to 2 and m is equal to 2. 2 square is equal to 4. 2 square is equal to 4. This is going to give a sum of 8. Either you can get 5 or you can get 8 in other set of value. There is no possibility of getting 6 here. That's why we are going to mark this as false. So the explanation here is given in words. When n is 1 and m is 2, we get 5. When n is 2 and m is 2, we get 8. The sum of n square and m square will be greater than 6 but not equal to 6. 8 is greater than 6. In that case, they are marked as greater than 6. If you take n is equal to 3, then it will be 9 plus 4 which is equal to 13. In that case also it is greater than 6. So the expression can be generalized as greater than 6 but not as equal to 6. That's why it is false. Let's check the E expression. There is a n value and m value. M plus n is equal to 4. This is and n minus m is equal to 1. If you take n is equal to 2.5 and m is equal to 1.5. M plus n will be 2.5 plus 1.5 which is equal to 4. N minus m will be 2.5 minus 1.5 which is equal to 1. This condition is true for these values, but they are not true for the discourse of integers. So we can mark E also to be false. This is what is explained in the statement. Since there do not exist integers that make the equations true, the statement is false. We know D and E are definitely false. When you remove D and E from all the options, the only option that is left out here will be option number 1, which makes A to be true. The possibility is given in the statement as we can always find an integer m bigger than n square. Option number 1, A, B, C only will be the right answer. Next question. The chairs of an auditorium are to be labeled with a letter followed by a positive 2 digits integer, where labeling is starting with A01. How many maximum possible chair could be labeled in this way? This question can be answered using the product rule. Suppose that a procedure can be broken down into a sequence of 2 tasks. If there are n1 ways to do the first task, and for each of these ways of doing the first task, there are n2 ways to do the second task. Now we can just interpret the question in this way. There are 2 kinds of labeling here. One is with a letter and the other will be followed by a positive 2 digits integer. If you take the starting, it is A01. First they have picked the letter, then they have mentioned the 2 digit integer. If there are n1 ways to do the first task, the first arrangement will be as per the alphabets A to Z. This will be the n1 ways, and for each of these ways of doing the first task, if you take the label A, you will have numbers from 01 to 99. This 01 to 99 will be for A row. Similarly for B, C and D till Z you will have 01 to 99. So the n2 ways are nothing but this 01 to 99. If there are n ways to do the task from A to Z, then for each of these ways, for each of A to Z, there are n2 ways to do the second task. For every row from A to Z, we will have 01 to 99 numbering. Then there are n1 into n2 ways to do the procedure. It means we have to just multiply both the numbers. That is what the product rule says. There are actually 26 letters given. So there are 26 ways to pick letters. Similarly, they say positive 2 digits number. And they have given the label is starting with 01. So what are the 2 digits number? You can take 0, 1, 2, 3 till 99 you will have 2 digits number. You cannot take 100 because it is a 3 digit number. So you have to count only till 99. In this way we can say there are 99 ways to pick integers because the count is starting from 1. Then the maximum chairs to be labeled will be equal to the number of letters into the number of positive integers. If we take the product rule, we can take this to be n1 and this to be n2. So the number of letters will be 26 and the number of positive integers will be 99. You will get the answer of 2574. Option number 2 will be the right answer. Next question. Arrange the following sets in increasing order on the basis of their cardinality. The number of elements inside the set is called cardinality. Just take the opening curly brace and close curly brace. See the commas here. Don't worry about what is present inside the comma. Just count how many elements are there with comma. Let's take A1 for example. We have outer curly brace. Then we have inner curly brace for 1, 2 with a comma here and then curly brace with 3 here. You have to count only the element that is present before the comma and after the comma. Inside the set you can have another set also. But regarding the cardinality of A1, you have to count only the elements present. So here it is 1 and it is 2. So 2 elements are present. One element is this one, comma the second element. How do you actually place elements in the set? Inside the curly braces, we will place the elements with commas. So count only the elements, don't worry about what are the elements inside. Regarding cardinality, this is how you have to work. A1 has 2 elements. Let's check A2. 1, 2, 3, 4. We are not worried whether it is a set with element 1 or only element 1. We are worried only about the count. B is going to have 4. A3. Do you have any comma separation here? No. The outer curly brace is having only one element and that inside element is only having multiple element. But for A3 there is only one element. So the cardinality is 1. Regarding A4, 1, 2, 3. The cardinality is 3. Regarding A5, 1, 2, 3, 4, 5. 5 elements are present. They are asking in the increasing order. Let's arrange A3, A1. So this is 1, this is 2. We have 3, 4, 5. 3 it is A4, 4 it is A2. And 5 it is A5. A3 set is option C, A1 set is option A, A4 set is option D, A2 set is option B, A5 set is option E. C, A, D, B, E. Option number 4 will be the right answer. Next question. A bit string of length 4 is generated at random. What is probability that it contains at least 2 consecutive zeros, given that the first bit is 0. When you take a bit string of length 4, you have 4 bits, bit 1, bit 2, bit 3 and bit 4. There are 2 conditions. It should start with 0 and it should have 2 consecutive zeros. It means 0 and 0 should be present together. So starting with 0 is any string having 0 in the first place should be selected. What are the combinations of consecutive zeros? The 2 consecutive zeros can be in the starting, it can be in this order, it can be in this order too. You can check here, it is starting with 0 and it is having 2 consecutive zeros this way and 2 consecutive zeros this way. Here it is starting with 0 and it is having 2 consecutive zeros. And another possibility is all the 4 bits will be 0. Here also you have starting with 0 condition fulfilled and 2 consecutive zeros condition fulfilled. They are saying at least 2 consecutive zeros should be present. So at least says it can be more than 1. Now what are the strings that can be taken? If you take 8421 code, the values from 0 to 7 will start with bit 0. The values from 8 to 15 will start with bit 1. For this purpose, we are not going to take 8 to 15 because it is going to start with 1. If you take 8, the value is 1000. You have 2 consecutive zeros here. That's not an issue. But does it start with 0? No. That's why after 8, we are not taking any digits. We are going to work with only 0 to 7. You can start marking like 000, 001, 010, 011 till 7 you can mark and then just add a 0 in the front. That will give you the 4-bit string. What are the possible 4-bit strings starting with 0? This is 0, this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7. If you apply them in 8421, you will get numbers from 0 to 7 in decimal. There are totally 8 number of strings. The first bit is 0. Now we have to check which numbers have consecutive zeros. This one has 2 consecutive zeros. This one has 2 consecutive zeros. Here also you have 2 consecutive zeros. Here you have 2 consecutive zeros. Here also you have 2 consecutive zeros. In 5, do you have consecutive zeros? No, it just starts with 0. But there is no 2 consecutive zeros. We are removing this one. Here you have 2 zeros in 6, but they are not consecutively placed. So we will remove even that. Then we have only the first bit as 0 in 7. The rest of the bits are 1. So this is also not going to be considered. How many 2 consecutive zeros are present here? 1, 2, 3, 4, 5. 5 strings have first bit as 0 and 2 consecutive zeros. There are totally 8 strings present. How many strings satisfy these two conditions? 5 strings. So the probability will be option number 3, 5 by 8. Next question, how much time does an algorithm using 2 power 50 bit operations need if each bit operation takes 2 power minus 38 seconds of time? Two values are given here, the number of bit operations and time for one bit operation. This is the time. We have to calculate for 2 power 50 bit operations. If we have a value for 1x and they are going to ask for 50x, what you will do? You will multiply 50 into the value of 1x. This is what we are going to do. The time for one bit operation into number of bit operations. The number of bit operation is 2 power 50 into the time for one bit operation is 2 power minus 38. 50 minus 38 will give, if you have minus 38 plus 50 or plus 50 minus 38, both will end with 2 power 12. The unit for one bit operation is given as seconds. So we can retain the seconds since we are just using multiplication operation. To convert seconds to minutes, we have to divide it by 60. To convert minutes to hours, we have to divide by 60. So for seconds to hours conversion, you have to divide by 60 into 60. So 3600 totally. Now there are possibilities in the option with minutes as well as hours. So we will first convert to minutes, check that and then go for hours calculation. 2 power 12 can be written as 2 power 6 into 2 power 6. What is 2 power 6? It is 2 power 3 into 2 power 3. 2 power 3 is 8. 8 into 8 will give 64. 2 power 6 will be equal to 64. So this is 64 into 64. Now we will express 2 power 12 as 64 into 64. Since the unit is in seconds, we are going to convert into minutes. So we are going to divide by 60 to convert this to minutes. We will try to cancel this. This will be 15 fours and this will be 16 fours. We will divide 16 by 15. 1 0. So this is going to be 1 point something. So this can be taken as 16 divided by 15 into 64. This part is going to be just a fraction of 1 point something. So this is 1 point something into 64, which is ultimately 64 minutes. When you want to convert 64 minutes to hours, you have to divide it by 60 again. So 64 divided by 60. This can be written as 60 plus 4 by 60, which is equal to 1 plus 4 by 60. This is 1 hour plus 4 by 60 minutes. 4 by 60 is actually 1 by 15. 1 by 15 is not going to be a so big number, and there is no possibility of having 10 minutes and 30 minutes hereafter. We can rule them out because we have got solid 1 hour. What we have to check is whether it is 1 hour or 1.5 hours. 1 by 15 is not worth for 30 minutes and all. So here we can conclude the answer to be option number 1, 1 hour. Option 1 will be the right answer. When you come to this part of computation, you can easily say this is 1 hour plus some fraction of minutes. If they have given specific minutes, then you have to work for this. But they have given a big gap between 1 hour and 1.5 hour. There are 30 minutes in between. So you need not go for this small calculation for 1 by 15 and all. So you can easily conclude this as 1 hour and rule out even option 4. Next question. Z is a set of integers. Z multiplication forms group if multiplication is. A group has to satisfy 4 properties. The first property is closure. The second property is associativity. The third property is identity. And the fourth property is inverse. If the operation holds all these 4 properties, then it is definitely a group. First, we will check whether all the 4 options are satisfying the closure property. What is closure? For any 2 elements A and B in G, the result of the operation A into B is also in G. It means when you solve the expression in the right hand side, the value that you get should be a part of integer. Let's check the first option. Integer addition will always be a part of integer. If you add two integers and a constant 2 to it, will it become decimal point or what? No, it will stay as integer. So closure property is okay for option 1. Let's check option 2. This is just a symbol of expression which says A and B are under multiplication operation. You need not confuse left hand side, just check right hand side. So if you multiply 2 into A and add it with B, it will still be a part of integer group. So 2 is also satisfied. Let's go to 3. When you involve addition, multiplication and subtraction operation with integers, the result will still be integers. But when you involve division operator in integers, you cannot always be sure that it will end up with integer itself. Say for example, if A is equal to 1 and B is equal to 1, 1 plus 1 will give 2, 2 divided by 2 will be 1. This is an integer. Let's take A as 1 and B as 2. Now this will be 1 plus 2 which is equal to 3. 3 divided by 2 will be 1.5. Here this is not an integer. Once it gets into decimal number, we can term it as a real number. Here the question is about the set of integers. Since the evaluation of A plus B by 2 may result in decimal numbers or real numbers, we can say 3 does not hold closure property. When the first property itself is not true, definitely it is not going to be a group under multiplication operation. So we can rule out option 3 here itself. Let's check option 4. A square plus B. When you are going to square any integer, you will get integer only, and adding integer to the square of a number will also result in integer. So 1, 2 and 4 are holding the closure property. Now we have to check for associativity property. Let's take the first option. A comma B under multiplication is A plus B plus 2. Associativity property states that A into B into C will be equal to A into B into C. This is what we are going to check now. But we have only two elements, so we are going to work with that. Let's take the left hand side. A into B into C. What is A into B as per the question? It is A plus B plus 2 into C. Now just consider the whole expression as A and C as B. Expand the expression as A plus B plus 2. This is A plus B is actually C now. Plus 2 will be followed from the question expression. A plus B plus C plus 4. This is left hand side. Let's check the right hand side. A into B into C. B into C can be expressed as B plus C plus 2 from the question. The expression given here. Now consider this as A and consider this as B. A plus B plus 2. You have to expand it in this way. What will be the answer? A plus B plus C plus 4. Is LHS equal to RHS? Yes, it is equal. So we can say first expression is holding associativity property. Let's check for the second expression. It is 2A plus B. Now let's go for the left hand side. A into B into C. Instead of A into B, we can substitute 2A plus B and let this stay as C. Consider this to be A and this to be B now. How do you express it in the form of question expression? 2 into A. So this will be 2 into A plus B. 2 into 2A is 4A plus 2 into B is 2B plus C. Just take the right hand side. It is A into B into C. This is equal to A into express B into C in the form of question expression 2B plus C. This is A and this is B. The complete expression is B. which is equal to 2 into A plus the B expression should be written as it is. 2A plus 2B plus C. This is the right hand side. Compare LHS and RHS. LHS is not equal to RHS, which says second expression is not going to hold associative property, which says that option 2 is also out of the race now. Let's check for the fourth option. This is A square plus B. Let's take the left hand side. A into B into C, which is equal to A square plus B into C. This is A and this is B now. A square is A square plus B, the whole square, plus B is C here. So instead of A, I am placing A square plus B. Since we have to square up A, I am just squaring up the full term together. A power 4 plus 2A square B plus B square, and this is C. Let's get into the right hand side. A into B into C. Here we have A into B square plus C. Now this is A and this complete expression is B. A square plus B has to be written as it is. So the B term is B square plus C here. This is the RHS. Just compare this expression and this expression or these two expressions. We can say LHS is not equal to RHS, which states that option 4 is also not holding associative property. Since only one option is crossing both the properties without checking 3 and 4, we can say option 1 will be the right answer. In case if all the 4 expressions are going to hold closure and associativity, then you have to go for identity checking, then you have to go for inverse checking. Next question. Arrange the steps of mathematical modeling. What is mathematical modeling? In mathematical modeling, we take a real world problem and write it as an equivalent mathematical problem. We then solve the problem and interpret its solution in terms of the real world problem. What are the steps involved there? First step is formulation. In formulation, we have 3 steps again. We have to state the question, identify the relevant factor, and then go for a mathematical description. After formulation, we have finding the solution. We have interpretation of the solution in the context of real world problem as the next step. Then we have checking or validating to what extent the model is a good representation of the problem being studied. We can see in the form of a diagram. Formulation of the problem, solution of the problem, interpretation of the solution, checking or validating the solution. Once this step is over, where we have marked the arrow, it is again going to formulation of the problem. So if you are not satisfied with the solution, or if we find the model is not a good representation of the problem, then we have to go for reformulation. These are the steps given. Now we will arrange it in order. First process is formulation mathematically. So B has to be in the first place. The remaining options can be ruled out. After B, you have to find the solution. This is similar to solving it mathematically. So B will be followed by C. This one is over, this one is over. Since we know C is following B, it is not option 2 also. Option number 1 will be the right answer. So what will be the next step? We have to check whether the solution is perfectly working for the data. Solution fitting with data is the next step. A will be coming next. We have to repeat formulation if it fit worst with data. So once you are not okay with this step, you have to go for reformulation. You have to first check whether data fitting is right. If you find it to be a worst fit, you go for repeat formulation. Finally, you go for interpretation of results, which is E. Once you formulate, you have to go for solving part. That is what they say, finding the solution. Interpretation of the solution in context of real world problem is what we say fitting the data. So if formulation is option B, Finding the solution will be option C. Interpretation of solution is option A. We have to check whether it's a good fit or not. This will be D. And the reformulation part follows this D. And finally, once you get some good value or optimal value, you go for interpretation of results. Interpretation of solution is different from option E, interpretation of results. Interpreting the solution means you are checking the solution with the data. But interpreting the result is after you complete the problem and find some optimal value, you are interpreting the results. Next question. Now we will get into the LPP set of questions. A firm can produce, a firm in the sense a company, a firm can produce two type of cloths, say A and B. Three kind of wool are required for it, say red wool, green wool and blue wool. 1 unit length of type A cloth needs 2 yards of red and 3 yards of green wool. 1 unit length of type B cloth needs 3 yards of red wool, 2 yards of green wool and 2 yards of blue wool. The firm has only stock of 8 yards of red wool, 10 yards of green wool and 15 yards of blue wool. It is assumed that income obtained from 1 unit length of type A and type B cloths are rupees 30 and rupees 50 respectively. Now we will put a table and then fill all the necessary details. 1 unit length of type A cloth needs 2 yards of red wool. So we can fill 2 here, 3 yards of green wool. And there is no mention about blue wool. Coming to cloth B, it needs 3 yards of red wool, 2 yards of green wool and 2 yards of blue wool. The firm has only stock, so the maximum stock is given here. Red wool is 8 yards, green wool is 10 yards, blue wool is 15 yards. And income is given for every type of cloth here. Type A and type B cloths are rupees 30 and 50 respectively, means A will be having rupees 30 and B will be having rupees 50. Using this table only, we are going to work with the upcoming 5 questions. Certain books have made this table in vertical way. I'll just show you the table. In case they ask about objective function, you have to choose the income column here. Here it will be income row. When they ask about maximum stock, you have to pick this stock row. Here it is the maximum column. So you have to know which row or which column to pick based on the table that you put. I have seen many of the books follow this kind of table, but I thought this is better for our understanding. So I am going with this horizontal format only. Now let's see the first question. Which of the following will be appropriate objective function for the given problem? What is the objective of any company? To create some kind of income and see some profits. Here which is associated with profit? The money part. Here they have mentioned it as income obtained from type A and type B cloths. So in order to maximize the income, you have to work with the income column here. So let's take the cloth A's denotion as X and cloth B's denotion as Y. Now the objective function can be written as Z is equal to, the income value should be considered here. So it is 30 into X plus this one 50 into Y. Now we have to think whether this is a minimization problem or maximization problem. This will be a maximization problem because you have to maximize the income. The company has to maximize its income based on the stock it has. So here this will be maximization function. Option number 3. 30x plus 50y will be the right answer. I'll just give you the interpretation of the other options. 2x plus 3y is actually red wool column. 3x plus 2y plus 2z is actually B row. 3x plus 2y is green wool column. Next question. If x unit length of type A cloths and y unit length of type B cloths, then constraints formulate for LPP is. In fact, this should have been the first question because they are explicitly mentioning it as x and y. So they have mentioned Type A cloths unit length as X and type B cloths unit length as Y. Now we have to formulate the constraints. How do you take the constraints? Actually, you have to check whether the red wool is within the maximum stock, green wool is within the maximum stock, and the blue wool is within the maximum stock. Now we will frame the equations. 2x plus 3y and 8 is going to be placed here. Should I use less than or equal to or greater than or equal to? It has only stocks of. It means the maximum stock available is going to be 8 in terms of red wool, 10 in terms of green wool, and 15 in terms of blue wool. If 8, 10, 15 are going to be the maximum stock, the company has to use within that. If I say it is within that, it means 2x plus 3y should be less than or equal to 8. Let's take the next column. 3x plus 2y less than or equal to 10. What about the next column? It is 0x plus 2y less than or equal to 15. Since you have only one variable here, we can take this as y is less than or equal to 15 by 2. 15 by 2 will be 7.5. So this particular constraint can be written as y is less than or equal to 7.5. So this is for the red wool, this is for the green wool, and this is for the blue wool. Now check which of the options match these constraints. We have y is less than or equal to 7.5 in two of the options. So the rest of the options can be ruled out. Here y is less than 7.5, y is less than 7.5, both are right. We have 2x plus 3y is less than or equal to 8. This is actually blue's condition and this is red's condition. 2x plus 3y is less than or equal to 8, both are right. Coming to the green wool condition, 3y plus 2x. A is actually denoted by x unit and B is denoted by y unit. They have exchanged the unit here. It should be 3x plus 2y less than or equal to 10. So we can rule out even option 1. This is the green part. Option number 2. Y is less than or equal to 7.5. 2x plus 3y less than or equal to 8. 3x plus 2y less than or equal to 10 will be the right answer. Next question. When we formulate the LPP from the above given passage, which of the following is a objective function for the dual problem? So let's take the primal notation and dual notation. So let's see the primal actually for this problem. We found the objective function to be maximization problem. Z is equal to 30x plus 50y. Subject to the constraints are 2x plus 3y less than or equal to 8, 3x plus 2y less than or equal to 10, 2y less than or equal to 15. Do not reduce y's value, we have to convert into dual. Then we have x comma y greater than or equal to 0. Now regarding dual, convert maximization problem to minimization problem. They have used p as the minimization function notation. Minimize p is equal to, which value should I pick up? I have to pick up these three values and they have used the notation UVW. So this will be 8u plus 10v plus 15w. Subject to, we have earlier taken the column wise data to pick up the constraints. Now we have to pick up the row wise data. So from column we have to move to row in case of dual. So what is the row wise data here? 2, 3. So it will be 2u plus 3v and the value will be 30 here. Next we will have 3u plus 2v plus 2w and the value in the right hand side will be 50. What will be the sign that we have to use? All the less than constraints will be turning to greater than constraints. Less than or equal to will convert to greater than or equal to. So here it is greater than or equal to 30. Here also it is greater than or equal to 50. U comma v comma w greater than or equal to 0. They are asking only about the objective function. So minimize P is equal to 8U plus 10V plus 15W. This is perfectly matching in option number 2. Option number 2 will be the right answer. Let's check the other options. 5, 8 and 15. The values are actually 8, 10 and 15. There is no value called 5. 1 is ruled out. 15, 5 and 8. I don't know from where they have mentioned 5. So this is also ruled out. We have 10, 8 and 15. Actually the values are right, but they are interchanged. U is for red, V is for green and W is for blue. So this is U, V and W. But the order is changed here as 10, 8 and 15 and it is given as maximization problem, which is totally wrong. Next question. On the basis of available material, maximum total income is. I will solve this problem as usual in graphical method and simplex method. We will start with the graphical method. In graphical method, we have to take the constraints and make one of the variables as 0 at a time. Let's take the first constraint, 2x plus 3y less than or equal to 8, and we'll make x to be 0. What is y? Y is equal to 8 by 3. So here we should not use less than, we have to just keep it as equal to. Only then we'll be able to find this value. What is 8 by 3 actually? It is 2.6667 something. So it keeps on running. Then we have to make y as 0. Now x value will be x is equal to 8 divided by 2, which is equal to 4. The next constraint equation will be, again we have to remove the inequality first and then equate it to 0. First x is equated to 0. So we will have y is equal to 10 by 2, which is equal to 5. Then we are equating y is equal to 0, x is equal to 10 by 3, which is equal to 3.333. So as for now, we can have only one decimal point for plotting purpose. The third equation is 2y less than or equal to 15. So we will cut this less than again. Already x is 0, so y is equal to 7.5. Now we have to plot the points. The first equation gives rise to 0, 2.66 and 4, 0. First we will plot them. We are plotting 0, 2.66 and 4, 0. We will draw a line here. This constraint is over. Let's take the second constraint. It has the points 0, 5 and 3.33, 0. We will plot the second set of points. We have 0, 5 and 3.33, 0. We will draw another line here. Then we have the third constraint 0, 7.5. It will be parallel to the x-axis, but since it is not going to intersect with the lines in the bottom, we are not going to draw any line in the top now. We will check the intersection point in the graph now. We have the values 2.8, 0.8. Regarding the region that has to be shaded in maximization problem, from the intersecting part only you have to do that. So we have to shade this particular part completely. What are the points here? We have to consider this point 0, 2.666. We have to consider this intersection part. For this purpose only we are finding it 2.8, 0.8. Then this part 3.33, 0. The rest of the points we are not going to take it. The shaded region's coordinate axis will alone be considered here. Anything below this line will be shaded for this particular constraint. Anything below this line will be shaded for this particular constraint. The place where common shading point is the region that we will call as feasible region. So this is going to be x and this is going to be y. Let's calculate z is equal to 30x plus 50y from this. What is z is equal to 50 into 2.666? We have 133.33. It goes on. Then z is equal to 2.8 into 30 plus 50 into 0.8. So this is x into 30 and 50 into y. This will give a value of 84 plus 40, which is equal to 124. Then we have 30 into 3.33 plus 50 into 0. This is equal to 99.9. Now here comes an issue. The maximized income is there in 133.33, but here you can find x value is 0. So let's stop with this now. We will discuss the answer after solving in the simplex method. Let's get into the simplex method. What is the objective function? Z is equal to 30x plus 50y. Now we are going to solve this using simplex method. Whenever we have the inequality symbol less than or equal to, we have to go with the use of slack variables. It means we have to add a slack variable to the equation in the left hand side and equate it to the value in the right hand side. Let's add slack variables now. 2x plus 3y plus s1 is equal to 8. 3x plus 2y plus s2 is equal to 10. 2y plus s3 is equal to 15. I am just converting the inequalities to equations by adding slack variables. The slack variables are s1, s2 and s3. The first step in simplex method is to find the basic feasible solution. In graphical method, we turn either the x value as 0 or y value as 0 and then find the other value to plot in the graph. Here you have to make both x and y to be 0 and find the s1, s2, s3 value. So s1 will be equal to 8 when x and y are going to be 0. S2 is going to be 10 and S3 is going to be 15. This is the basic feasible solution. Once you add the slack variables to the constraint equations, the objective function should also have all those slack variables. Let's have as 30x plus 50y. We know the slack variables are not going to be a part of objective function. So we'll just use it with the 0 coefficient. Now let's go to the simplex table. We have the basic feasible solution variables here. Slack variable S1, S2 and S3. What are the coefficient values in objective function? They are 0. So we have placed 0 here. CB is coefficients of basic variable in the objective function. We have x variable, y variable, s1, s2 and s3 in the objective function. The respective values of the coefficients are placed above the basic variable row, that is Cj. For x it is 30, for y it is 50, for s1, s2 and s3 it is 0. We have the right hand side as RHS. To calculate ratio, we have a separate column. Now let's start filling the values. First equation has to be taken. 2x, 3y, s1 is just s1, so it is 1 into s1. You don't have s2 and s3 in first constraint, so let's add 0 here. What is the right hand side? It is 8. What about second constraint? 3x plus 2y. And you should have 1 under S2, S1 and S3 will be 0 and the right hand side is 10. Take the third constraint, 2y plus S3. X is 0, y is 2, S3 is 1. S1 and S2 are also 0. The right hand side is 15. We have to calculate Zj. It is the summation of product of coefficient of basic variables into a particular column. Let's take x column now. Coefficient of basic variables is 0. 0 into 2 plus 0 into 3 plus 0 into 0. It will ultimately give 0. Coefficient of basic variable column into a particular column, you have to multiply the values and then sum them together. This is what you have to do for Zj. We will do the same thing for y. 3 into 0 plus 2 into 0 plus 2 into 0. Once you have 0 in the CB column, every value will be 0 only. You should not do the same thing for RHS, only the variables have to be considered from the objective function. Now what is Cj minus Zj? 30 minus 0 is 30. 50 minus 0 is 50. And the rest of the values are also 0 here. Regarding pivot column, you have to choose the maximum positive value of Cj minus Zj. In case you use Zj minus Cj, you have to use the minimum value. So which is the maximum value here? Out of 30 and 50, 50 is the maximum value. So this will be the pivot column. And in fact we can say y is entering the next iteration. So this says y is the entering variable. Now we have to find the leaving variable. How should you do that? RHS divided by the pivotal column. What is the pivotal column? It is this one. 8 by 3, 10 by 2, 15 by 2. 8 by 3 will be 2.666. 10 by 2 will be 5. 15 by 2 will be 7.5. In this ratio, you have to find the least value. Minimum value has to be taken. The minimum value row is this one. It means S1 is the leaving variable. So the pivot row will be minimum of ratio. This is going to be the pivotal row. The intersection of pivotal row and pivotal column will be the pivot element. Which is the pivot element here? 3 is the pivot element because it is the intersection of pivotal row and pivotal column. This is how we have to find the pivot element. Based on this pivot element only, we are going for the next iteration. So with this, the first iteration is over. For the next iteration, we have to just continue. What is the entering variable? Y. What is the leaving variable? It is S1. Instead of S1, I have to place Y here. Y is having coefficient of 50. Now, how should I place the Y row? I have to make the pivot element place as 1. What operation if I do in the pivot row? This particular 3 will become 1. I have to divide 3 by 3, only then I will get 1. In order to bring this to 1, I have to divide the whole row by 3. That is the first operation I have to do. So I am taking the old S1 value 2, 3, 1, 0, 0, 8 and I am dividing it by 3. This will give 2 by 3, 3 by 3 is 1, 1 by 3, 0 by 3 is 0, 0 by 3 is 0 and this is 8 by 3. Don't put decimal point now itself, have it as fraction, it will be useful for calculation. So this will be the new Y row. We have 2 by 3 in place of X column, then Y will have 1 as it is. Next value is 1 by 3, we have 2 zeros, then we have 8 by 3. The next two variables are S2 and S3 and their respective coefficients are 0 and 0. So we have already picked 50 from the objective function, that is the respective coefficient of Y variable. How should you find S2's new row? Only the pivot element should be 1 there. The remaining entry should be 0. Now we have to do certain calculations to make this particular place as 0. So let's take the S2 value first. The old S2 row is 3, 2, 0, 1, 0, 10. In order to make this 2 as 0, you can either multiply y by 2 and then go for subtraction, or you can directly multiply it with minus 2 and then go for simple addition. Whichever way you are choosing, it's fine. We are actually choosing this way. You have to multiply with the new y row. What is y into minus 2? 2 by 3 into minus 2 will give minus 4 by 3. 2 into minus 1 will give minus 2. Minus 2 into 1 by 3 will give minus 2 by 3. Minus 2 into 0 will give 0. Minus 2 into 0 will give 0. Minus 2 into 8 by 3 will give minus 16 by 3. Now I have to add them. 3 minus 4 by 3. 3 3s are 9. 9 minus 4 is 5 by 3, 2 minus 2 is 0, this is minus 2 by 3, 10 minus 16 by 3, 30 minus 16 is 14 by 3. This is the new S2 row. So let's fill 5 by 3, 0, minus 2 by 3, 1, 0, 14 by 3. Now we have to find the same thing for S3. I have to make the second column 0. I will take the old S3 value 0, 2, 0, 0, 1, 15. Since I have 2 again, I have to use the same values for S3 also. So I will just copy the same values, minus 4 by 3, minus 2 by 3, 0, 0, minus 16 by 3. Why am I copying the same value is because I have to multiply y by minus 2. Since I have already multiplied in S2, I am using the same values here. Now I have to add this together to find the new S3 value. 0 minus 4 by 3 is minus 4 by 3. 2 minus 2 is 0. 0 minus 2 by 3 is minus 2 by 3. 0 minus 0 is 0. 1 minus 0 is 1. 15 minus 16 by 3. 15 3s are 45. 45 minus 16 will give 29 by 3. So let me copy the new S3. Minus 4 by 3. 0. Minus 2 by 3. 0. 1. 29 by 3. Now we have to calculate Zj again. What is 50 into 2 by 3? It is 100 by 3. 50 into 1 will give 50. Since there is 0, I am not considering the other rows, I am taking only 50. Next we have 50 by 3. Then we have 0 into 50, 0 into 50. So you should not calculate this for RHS. Let's stop here. Now we have to find Cj minus Zj. 30 minus 100 by 3 will be 90 minus 100 by 3, which is equal to minus 10 by 3. 50 minus 50 is 0. 0 minus 50 by 3 is minus 50 by 3. 0 minus 0 is 0. 0 minus 0 is 0. In Cj minus Zj, you have to pick the maximum positive value. But here you have only 0 entries and negative values. It means you have to stop the iteration. Now what is the only value you have? Y is equal to 8 by 3, which means x is equal to 0. Now what is y is equal to 8 by 3? It is 2.666. Now substitute x is equal to 0 and y is equal to 2.666 in z. You will have z is equal to 50 into 2.666. Since x is equal to 0, 30 into x will also be 0. Z is equal to 133.33. Based on the number of 0.6, this 0.3 will also go. This is what we have got in Simplex method. Now we will just get into the comparison of results. Now they are asking on the basis of available material, maximum total income is. The subsequent question in this LPP set is, how many unit length used for cloth A when income is maximized? It means they are asking the value of x. Cloth A is x and cloth B is y. If they say x has any of those values, it means x cannot be 0. So you cannot choose this answer, whether it's graphically found or by Simplex method. You cannot consider this answer. X cannot be 0 when the next question is depending on the x value. So the only option available here will be 2.8 as x value and 0.8 as y value. In that case, what is the maximum income here? 124. On the basis of available material, the maximum total income is 124. Option number 2 will be the right answer. Next question, we got 124 from x is equal to 2.8 and y is equal to 0.8. Now the question is, how many unit length used for cloth A when the income is maximized? The maximum income that we found is 124. In that, what is the unit length used for cloth A? They have mentioned it is x unit length. So they are asking the value of x here. Option number 3, 2.8 unit will be the right answer. So cloth A will be x is equal to 2.8 and cloth B will be y is equal to 0.8. With this we are completing unit 1 solutions.